I am Priyavashri, Assistant Professor, Department of Computer Science from Dr. SNS Rajalakshmi College of Arts and Science. Today, we are going to explore something that feels straight out of science fiction, but it is already part of our daily lives. That is an augmented reality or AR for short. You may not realize it, but AR is already around us. From filters on Instagram and Snapchat to shopping apps that let you try on clothes virtually to games like a Pokemon Go, all of these use AR. But here, the catch, none of this world work without something called AR tracking. That's what we are going to dive into today. So stay with me till the end because I will take you through the basics, the types, the math behind it, real world applications, and finally where this technology is heading in the future. First, what is AR tracking? Let's begin with the foundation. In simple words, AR tracking is the process that allows digital objects to stay aligned with the physical world. Imagine pointing your phone at an empty table and suddenly you see a 3D coffee mug appear on it through your screen. That coffee mug looks like really on your table because AR tracking keeps it fixed in the right place. Without AR tracking, digital objects would float around randomly and the whole AR experience would fall apart. Now, AR tracking comes into two major approaches. First is marker-based tracking, where a predefined image or symbol acts like a trigger. Markerless tracking, where no marker is required. Instead, the system uses a natural features or your location. Then introduction to marker-based tracking. Let's talk about the marker-based method first. Imagine you print a QR code on paper. When you scan it with your phone, a 3D animation of your product appear right on top of the code. That is marker-based AR. How does it works is the camera looks for a specific visual markers. Once detected, the system calculates the camera's position relative to that marker. Finally, digital content is placed exactly at the spot. The advantage is it accurate, fast and doesn't require heavy processing. The disadvantages is you always need a physical marker. If it is not visible, AR won't work. The real-time example is early AR apps using the AR toolkit where the simple black and white square marker could trigger the 3D objects. Types of markers. The types of markers, not all markers are the same. There are different categories. First is the template marker, then 2D barcode markers, imperceptible markers. There is 3. Okay. The template markers is the simple shapes or patterns like a square with a unique design. The 2D barcode markers, the QR code or data matrix codes, these can store informations and also serve anchors for AR content. Example, scanning a QR code to display the product details in AR. In template marker, the example AR toolkit hero marker, square with unique patterns. In imperceptible markers, these are hidden, not visible to the human eye. For example, marker using the infrared light. These are often used in AR art installations where you don't want the markers to spoil the visual beauty. So depending on the use case, the developers choose which type of markers works best. Then camera pose and identification. Once the marker is detected, the system needs to figure out where is the camera is positioned. This is called the camera pose estimation. It's like asking, is the camera looking from above, from the side or at the angle? The AR system calculates this using computer vision. It detects the marker's edge and corners, matches it with the stored patterns, and then computes how the camera is rotated and moved in space. Example, with Fourier SDK, you can scan a marker and see a car model appear. If you tilt your phone, the car remains fixed because the system continuously updates the camera. The math behind it is for those who enjoy the technical side. Let's talk about the math briefly. AR use something called a homography matrix, that is a 3 into 3 matrix that maps points from the markers to points on the camera's image. This matrix is then broken down into two parts. One is the rotation matrix, which tells how the camera is tilted. The translation matrix, which tells how far the camera has moved. Together, these form a 4 into 4 transformation matrix. What this means in practice, if you move your phone around, the AR object still looks fixed in place, as if it is really sitting on your desk. Example, the IKEA place. You can place a digital sofa in your living room. Even when you walk around with your phone, the sofa stays exactly where you put it. Next is the markerless tracking. Now let's step into the modern era. Markerless tracking. Here you don't need a QR code or any physical marker. Instead, the system uses the environment itself. It detects natural features like the edges, textures or corners and use them as a reference points. It often relies on SLAM, that means the simultaneous localization and mapping. Think of SLAM as a technology that build a 3D map of your environment while also keeping track of your device position in that map. The advantages works almost anywhere, no physical marker is needed. The disadvantages is need more computational power and may not work well in plain, textureless environments like white walls. Example, Google Lens, which identify the object in a real time. Google Map AR, which gives you walking direction overlaid on the real street. Next, the localization based augmentation, another form of markerless AR in localization based AR. Here AR systems uses the GPS, LiDAR and motion sensors to position the content. Example, Microsoft HoloLens. Engineers can wear it and see the holographic instructions overlaid directly on machinery. Or AR navigation apps can show the arrows on the road guiding you exactly where to walk. This is AR going beyond simple visuals and becoming a real productivity tool. Now let's look at where markerless AR shines in the real life. That means the real world example of markerless AR is gaming. The Pokemon Go uses the device orientation to place the characters. This is the most popular example. So retail, next IKEA place lets use a visualization furniture in their space, that is lets you try before you buy. Okay, then navigation. Navigation AR directions in Google Maps, AR walking directions. So education, next AR anatomy apps where students can see the 3D model of the heart pumping right in front of them. Then key technologies making this possible are Google AR Core and Apple AR Kit. Tracking methods in AR. Finally, let's break down the different tracking methods, that is a visual tracking, feature based tracking, hybrid tracking, initialization and recovery. The visual tracking uses the camera feed to detect and follow the points. The example is optical flow in AR card to track the surface points. The feature based tracking uses the algorithms like a shift and surf to detect the key points in the environment. So example, before your feature detection for robust tracking. Hybrid tracking combines the camera, depth sensors and motion sensors for more stability. The example is Microsoft HoloLens using the depth camera plus IMU for stable AR. Initialization and recovery. The process of starting the tracking and then the re-establishing it if the camera view is blocked. For example, AR Kit can recover and continue tracking after some walks in front of your camera. Future of AR tracking. Before we wrap up, let's look ahead. AR tracking is improving rapidly with AI and machine learning. In the near future, we might see AR glasses that don't need phones at all. Shopping where you can walk into a store and instantly see product details in the app. Education where classrooms use AR to bring the history, science, art to the life in 3D. The line between the digital and physical world will blur even more. So let's summarize. AR tracking is what makes augmented reality possible. There are two main types, that is a marker based and then markerless. We saw how math sensors and computer vision keep AR content stable and realistic. And finally, we looked at how AR is used in gaming, shopping, navigation and education. Imagine this, one day AR could replace our phone screens entirely. Instead of looking down at the device, we just look around and information will be overlaid onto the world itself. And that's why AR tracking is such exciting field. So thank you for this.